What is the argument of a complex number? The argument of a complex number is the angle between the positive real axis and the line joining the origin to z. In some textbooks, the argument may be referred to as the phase of z. Just know that it means the same thing. For all complex numbers, z equals a plus bi with the norm r. You can find the argument theta using any of these formulas. Sine of theta equals b over r. Cosine of theta equals a over r. Tangent of theta equals b over a. Let's investigate why these formulas are true by looking at a general complex number, z. z equals a plus b times I, and it lies at the coordinates a, b in the complex plane. Think of z as a vector starting from the origin to the point at a, b. Now, imagine that you draw a line from the end of the vector down to the real axis, like this. You might notice that z and its components form a right triangle, with legs of lengths a and b and hypotenuse r. The vector also forms an angle with the positive real axis. This angle is known as the argument of z, denoted by theta. An argument is measured using radians. So, how do you calculate the argument of z? By looking at the sine, cosine, and tangent of theta. The sine of theta equals the opposite leg over the hypotenuse, or b over r. The cosine of theta equals the adjacent leg over the hypotenuse, or a over r. Finally, the tangent of theta equals the opposite leg over the adjacent leg, or b over a. All of these expressions yield two values each for the argument theta. To find the correct one, you have two options. One is to use two of the formulas and choose the repeated value which both formulas yielded. The second is to plot z and choose the angle that lies in the correct quadrant. Now, let's look at an example where you're going to calculate the argument of a complex number. Calculate the argument of z equals 3 plus 3i. Let's start by plotting z in the complex plane. The real part of z is 3, and the imaginary part of z is also 3. So you draw a vector from the origin to the point 3, 3. Notice that this is in the first quadrant, so the answer should be an angle in the first quadrant. Let's use the third formula for the angle theta. Tangent of theta equals b over a. Here, both b and a are 3, so you get theta equals arctangent of 3 over 3, which equals arctangent of 1. Arctangent of 1 is pi over 4, which is in the first quadrant, and is therefore your final answer. Now let's look at a very similar example. Find the argument of w equals minus 3 minus 3i. Again, start by plotting w in the complex plane. The real part of w is minus 3, and the imaginary part of w is also minus 3. So you draw a vector from the origin to the point minus 3, minus 3. Notice that this is in the third quadrant, so the answer should be an angle in the third quadrant. Let's again use the third formula for the angle theta. Tangent of theta equals b over a. Here, both b and a are minus 3, so you get theta equals arctangent of minus 3 over minus 3, which equals arctangent of 1. Again, arctangent of 1 is pi over 4. This is in the first quadrant and therefore can't be your final answer, because w is in the third quadrant. At this point, you can either try to use one of the other formulas, Or you can recall that the tangent of theta equals tangent of theta plus pi. Pi over 4 plus pi equals 5 pi over 4. This places your number in the third quadrant and is therefore your final answer. For now, it might seem strange to care about the argument of a complex number. But knowing what the argument is and how you calculate it will become very useful in future videos. The argument of a complex number is the angle between the positive real axis and the line joining the origin to z.
Thanks for watching. Subscribe Infinity Math channel for more math videos.